Okay, so we need to review these 7 rules of exponents. I'm pretty sure everybody understands number 1. X to the second times x to the third equals x to the fifth. You have to have the same base in order for you to add the exponents, okay? That's why 2 plus 3 is 5, so x to the fifth is your answer right there. So let's just do a couple more with rule number 1. If I said, what is x to the fifth times x to the fourth, what's my answer going to be? X to the ninth. What if I had 3x to the fifth times 4x to the fourth? Then what is my answer going to be? Yeah, because it's all pure multiplication, 3 times x to the fifth times 4 times x to the fourth, you could multiply the 3 times 4 first and get 12. And then you could do the x to the fifth times x to the fourth, and you'll get x to the ninth, right? And it could get more fun, kind of like 3x to the fifth y to the second z times 2x to the fifth y z to the fourth. Okay, so what would that answer be? 6x to the 10th, y to the third, z to the fifth. Cool. I think we got rule 1 down. Okay, and this will be on our next assessment as well. Let's move on to rule 2. Rule 2 says x to the second to the third equals x to the sixth. Anybody, could you verbalize what's happening here? What's the rule that's happening here? You're multiplying, right? So when do we multiply? Like, why do we not multiply right here, 2 times 3, even though it says multiplication? Yeah, right here, it's because there's parentheses and you really have a power to a power. So in your notes, you could write down the number 2 for rule 2 and then write down power to a power. So when you have an exponent on an exponent, that's when you multiply. Power to a power multiply. 2 times 3 is 6. Okay? A power to a power, that's when you multiply. Now, if you're thinking, wait a minute, I'm confused. This says multiply. Why are we not multiplying? Why are we adding? Think about it. What is x squared? The explanation is this, that x squared is x times x. What's x to the third? That explanation is that it's x times x times x. And you are multiplying between these x's. So you really have x times x times x times x times x, which is a total of 5. That's why you're adding exponents, right? If you want me to explain this one, it's pretty simple. It says x to the second to the third power. The third power is really saying that you're going to multiply x to the second with itself 3 times. So that's really x to the second times x to the second times x to the second. And that's really x times x times x times x times x times x. And that's a total of 6 x's. But the shortcut is that a power to a power you multiply, right? That way you don't have to show all this work. That's pointless. So with that said, what is x to the second to the third to the fourth? Power to a power to a power. What's the answer? X to the 24. All you got to do is multiply. 2 times 3 is 6. 6 times 4 is 24. Cool? You get it? All right. Moving on to rules 3 and 4. So right here, whenever you have parentheses with an exponent on the outside, that's why both of these rules are together. All you have to do is distribute the outside exponent to each and every inside exponent term, okay? So this is, I would write down distribute. Okay, so this 3, the power of 3 is going to get distributed to the power of 1 on the 2. There's an invisible 1 right there. And of course, the previous rule says a power to a power you multiply. So when I distribute it right there, 3 times 1 is going to be 3, and that's 2 to the third. But 2 to the third you could actually do. That would be 2 times 2 times 2, which is 8. And then you distribute the 3 to the power of 2 right there. And of course, from the previous rule, a power to a power you multiply. 2 times 3 is 6. That's how we get x to the sixth. And then you distribute 3 times that invisible 1 on the power of y. 3 times 1 is 3. And that's how we get y to the third. Make sense? All we're doing is taking the outside exponent and distributing it to each inside exponent. And even if you don't have an exponent, there's an invisible 1. And it's the same when you have a fraction inside your parentheses. You still distribute it to every single power term. You take that 2, 2 times 3 is 6. 2 times the invisible 1 is 2. So you really have 3 squared, and 3 squared is really 9. Put that 2 on the 4. 4 times 2, power to a power, multiply. That'd be y to the 8th. That's why it's y to the 8th. Yay? Okay. Should we do more of those? Let's just do one more. Why not? So let's have some parentheses right here. Let's put a fraction here. Let's do 2x to the 3rd, y to the 5th. Let's do a z to the 4th right here. Let's say all to the 3rd power. What's my answer going to be? Well, let's start with distributing the 3 on the 2. What do I get up here? It's not 6. It's 8. Okay, and then when that was distributing it there, what about here? X to the 9th, and what about here? Z to the 12th, okay, and on the bottom, y to the 15th. Easy peasy, lemon squeezy. Okay, moving on. Oh, you're going to love this rule. Anything to the power of 0 equals 1. X to the power of 0 equals 1. 5 to the power of 0 equals 1. 1,248 to the power of 0 equals 1. Anything to the power of 0 equals 1. Now you might be thinking, why the heck is this equal to 3? Because what has the power of 0? Does the 3 have the power of 0? No, there's an invisible 1. Only the x has the power of 0, and this does become 1. See, the reality is this. You have 3 times x to the 0. So what do you do first in the order of operations? Do you multiply first, or do you do exponents first? Obviously, exponents. So you have to do x to the 0 first, and x to the 0 is what? 1. So you really have 3 times 1, which is why that's 3. Make sense? Okay, so anything to the power of 0 is 1. So if I were to say 4y to the power of 0, what's my answer going to be? It's going to be 4. Perfect. Now, it'd be a different story if I put in parentheses 4y to the power of 0 on the outside of the parentheses. Then yeah, your job is to distribute it to each one, and everything would have the power of 0, which would all become 1. But the reality is all of it to the power of 0 is always 1. It doesn't matter what's in there. If it's in parentheses and the power of 0 on the outside, it will be 1. Okay, rule 6. This is the negative exponent rule. I apologize for rushing through this. This is all stuff that we should have already mastered in Algebra 1. But I'm just reviewing it. And anything with the power of a negative exponent, you're going to have to grab it and move it to the other side. So you have x to the negative 2 over x to the positive 3. Whenever I see a negative exponent, I actually circle it and draw an arrow to the other side. So this guy doesn't have a negative exponent. It's going to stay down there, so I left it down there. This guy moved down, and now you could see that it's down here instead of up here. It moved down. And then you could apply rule 1, which says that if you're multiplying with the same base, add those exponents. So you have nothing left up on top, which is a 1 up there, and you have the x to the 5th on the bottom. Any questions? Let's do some more. What if I said, what is 1 over x to the negative 5? What's my answer going to be? X to the 5th power over 1, which is just x to the 5th. Pretty easy, right? What if I had x to the 2nd over x to the negative 5? That goes up. It becomes x to the positive 5. It's no longer negative 5 on the bottom. And on top, x to the 2nd times x to the 5th is x to the 7th. Cool? Okay, let's go for the last rule. Okay, last rule. You're going to love this last rule. We already know this last rule. Everybody knows that 3 over 3 is 1, right? Everybody knows that 5 over 5 is 1. 10 over 10 is 1. Negative 5 over negative 5 is 1. Whenever you divide something by itself, it eliminates and becomes 1. So this is the concept that if you think about how many x's are up here really, x squared is really x times x. How many x's are really down here? There's 3 of them, 1, 2, 3. So the x divided by x cancels, the x divided by x cancels. And what's left over? Nothing on top, so you put a 1 up there. And there's 1x left on the bottom, so that's your answer there. So you're not actually going to be canceling things out. That's just so you could understand it. In reality, it becomes a subtraction problem in your head, and you realize where they're left over. So for example, if I told you x to the 5th over x to the 10th, how many x's cancel with how many? 5 cancel with 5. So there's no more x's left up on top. Like nothing. All 5 cancel with 5 of the 10, and there's 5 left over on the bottom. So my answer is 1 over x to the 5th. What do you think? Yeah? If I had, let's say, x to the 8th over x to the 6th, then what's my answer going to be? X to the 2nd over 1, and you could just leave it like that, x to the 2nd. Anything over 1, you don't have to write over 1. But if you do have nothing left up on top, you do have to put a 1 up there. Okay? So, of course, it could get a little more interesting. I could do something like x to the 2nd, y to the 3rd, z to the 5th, over x to the 5th, y to the 3rd, z to the 4th, right? So how about them x's? What's left over on top? What's the only thing left over up on top? Z. Why? Because z to the 4th, all 4 z's cancel with 4 of these, leaving you 1 left over. What about the x to the 2nd up on top? Both of those x's cancel with 2 of the 5, leaving you 3 on the bottom. So you'd have the x to the 3rd left on the bottom. And what about those y's? The y to the 3rd cancels with the y to the 3rd. So there are no y's left anywhere, right? So there's your answer, z over x to the 3rd. And of course, it gets even more fun when you combine all the rules together and you have to apply all the rules together. So we have our worksheet here. Number 1, super easy. What's the answer? B to the 7th. 4 plus 3 is 7. 2's ridiculously easy. 3. So 3, there's 2 options here. There's 2 rules to apply. You could apply rule 1, where if you're multiplying with the same base, what do you do with the exponents? You add them. Or you could also move the terms to the other side because negative exponents have to get moved to the other side. I want to go with rule 1 first. And if I do rule 1 first, I will get a to the negative 7. Are you with me? And then after that, any term with the negative exponent, you have to grab it and move it to the other side of the fraction. What fraction? Go ahead and put a fraction bar right there. If you move that a to the negative 7 down, it'll become a to the positive 7. And you have nothing left up on top, so you have a 1 up on top, and there's your answer, 1 over a to the 7th. Sound good? Number 5, anytime you have parentheses with an exponent on the outside, you distribute that outside exponent in. So that goes right there. You'll have a 2 squared. That goes right there. You have an x squared. What is 2 squared? That's 4. So you have a 4x squared. And you do the same over here. Distribute the 2. You're going to have 4 to the 2nd. Distribute the 2. You're going to have y to the 2nd. What is 4 to the 2nd? That's really 16. And then bring down the y to the 2nd. Now keep in mind that we are multiplying. We're multiplying. So everything's multiplication. 4 times x squared times 16 times y squared. So we're going to rearrange it. 4 times 16 times x squared times y to the 2nd. And 4 times 16 is 64, x squared, y squared. That's your final answer right there. So anytime you have an exponent on the outside of the parentheses, you distribute it to the inside. Anytime you have a fraction and you have like terms on top and bottom, you start eliminating them, right? It's like subtracting and canceling. So for example, how many w's do I have on top? How many doubles do I have on the bottom? 3. So 1 cancels with 1 of the 3, leaving us 2 on the bottom. All 5 z's on the bottom, all of these guys completely cancel with 5 of the 7, leaving me 2 left over up on top. So we're canceling, we're writing what's left over. And not only that, we have some numbers here. What is 24 divided by 3? 8. So when I write my answer, the number 8 is up on top. What else is up on top? A z squared. What's on the bottom? W squared. There's your answer. Cool. I'm not going to do all of them. Obviously, we're running out of time, but you do have answers on Google Classroom, so you could double check your answers as you go. And down here, this is easy stuff. It's just distributing, and of course, you're going to be adding exponents when you're multiplying. So yeah, let's work on this. Check your answers on Google Classroom, and you should be ready for this portion of the assessment on exponents.